Hi, and welcome to the first Chem 2300 seminar, where you're going to learn how to use the Protein Data Bank to not only retrieve structural files, but to view them. So to get started, there's various ways to do this. Probably the most straightforward would just be to Google Protein Data Bank, and it will take you right there. Today what we're going to do actually is search this based upon the PDB IDs. That's where you enter at the very top up here. So if you know what the ID number is of the protein you're interested in, you can just type it right in here and it will take you directly to it. In the next seminar, we'll show how to do a keyword search and how to narrow down to get structures when you don't necessarily have this ID number. But for now, just type in 1CYO, and this will take you to the protein that we're going to use for this exercise. It's bovine cytochrome B5. So the cytochrome B5s are small electron transfer proteins that contain the iron cofactor heme, and they do have various functions that you might get to if you take metabolism. But for now, we're just interested in the fact that it's a small protein, and we can view it quite easily. And on the left-hand side is where you can see a static structure of the protein. If you wanted to find more information about this protein, such as the sequence, what it's similar to, what the structure looks like compared to other proteins, and also the literature, the papers that are associated with this, you can get them here. Also, if you wanted to download the structural file, if you had your own molecular graphics program loaded onto your computer, you could download that file here on the right-hand side and select a PDB format. So if you had a standalone program like PyMol, which we use in third year, you could do this. But today we're just going to look at these structures actually within the window of the browser, which doesn't require you to download any program or anything else, just have access to, say, Safari or Chrome or things like that. So if you go over to the left-hand side and see the image, down here it says View in 3D, just below the picture of the protein. There's two options you have. NGL actually gives you a higher resolution image. Looks a lot nicer than the GSMOL, but they both work. So if you click on this, it will open up a new panel. And now you can see the structure. The default is to show this in cartoon and colored with the amino terminus in blue and the carboxy terminus in red, so you can find your way around the protein chain quite easily. And the cofactor, in this case, referred to as a ligand in the program, is displayed in ball and stick fashion. The display options are on the right-hand side, so you can change these to suit your purposes. And if you click and drag, you can turn the structure around. You can also zoom in, zoom out, and all kinds of things. It's much more effective than looking at static images such as we have in PowerPoint during the lectures. So this is actually the way I prefer to look at structures myself. And with time, and not much time actually, you could probably get quite familiar with this as well too. So there's a few views that are useful to have. Since we talked about secondary structure, we have need then to say view this according to the secondary structure elements, and the program lets you do that quite easily. So if you go to the right-hand side and go to where it says Style, you can select from the drop-down menu different things: cartoon, space fill, licorice. Licorice will look like this, and will show you exactly all the atoms present. And you can click on each one of these amino acid side chains and it will identify it for you. So if we click here, the residue pointed up on the right, it will tell you which one that is. The glutamic acid residue, number 44, and it actually tells you the specific atom that you clicked on. That's not really too important for us right now. And we do want to actually look at the secondary structure, so we can get rid of those side chains then. We go back to Style and go and select Cartoon again, and it goes back to that. And now we want to color it according to secondary structure. So if you go over to Color, right now it's Rainbow, drag down, and you can find by secondary structure. And now what it does is it shows the alpha helices in pink and the beta sheets in yellow. So it's a very quick way to see what elements of secondary structure occur within a protein. There's a few other things you can do. For example, you can change the style to space fill, which shows each atom according to its van der Waals radius, so you can see how close those atoms pack against each other. There's another interesting way of looking at these structures, which is called surface, and this shows the solvent accessible surface. So if you wanted an idea of what the shape of the protein was, this is essentially what it would look like if you were approaching it from the outside. So you can see that the surface is very dimpled. It's almost, it's very compact. It's a typical globular protein, but you can see there are lots of protuberances and little indentations within it as well too. That's typical for most proteins. So basically that's it right now. Along with this seminar, there is a PDF that has some structures that you can load in there that have different examples of patterns of secondary structure, arrangements of secondary structure. So you can go through them now, and you can just put them into the search bar at the very top and do the same thing. So that concludes the presentation, and good luck, and I'll be talking to you live then tomorrow when you see these things.